Today's lesson from section 1-4 in our textbook, Graphs of Functions. Take a look at the learning goals that we have. Use functions to solve real-world problems. Determine the domain, range, and values of a function from its graph, and apply the vertical line test for a function. Things that you have seen previously in some of the sections in this chapter. Domain, range for sure. Definition of a function, and now the vertical line test as well. So let's look and see what we do remember. Let's double check that we have our definition down, and let's just isolate that. Our definition, a relation, is a relationship between two variables such that each value of the first variable is paired with one or more values of the second variable. Some of you will say that sounds awfully familiar to a function. The difference in a function, it says a relationship between two variables such that each value of the first variable is paired with exactly one of the second. So how our variables are paired is key. A relation first is paired with one or more values of the second. This is basically saying any set of ordered pairs, because your x value could be with y, it could be repeated, it could not, because it says one or more values. So if you want to say a simple definition, any set of ordered pairs. Okay, now make sure, knowing you understand that, you say, well, wait, look at this statement. All functions are relations, but all relations are not functions. So think of it this way. If you have any set of ordered pairs, any set, will that always, and that's where we're looking right here, any set of ordered pairs, will that always be a function? No, because you can write some combinations where the first is paired with 2 seconds and it wouldn't work. But all functions, which are the exactly, each first is paired with exactly 1 second, are examples of ordered pairs. So all functions are examples of ordered pairs, but not all ordered pairs are example of a function. Vocabulary that we have to keep in mind. So we will test it on some ordered pair charts, XY tables. Are they functions? Are they a relation? Or are they both? So the key is here, if you look at the ordered pairs, and we'll just focus on one of them to start with. If we have ordered pairs, x and y, our definition was each x is paired with exactly one y. Now, I believe these ordered pairs are random, so they don't go highest to lowest or anything like that. So make sure you look at the entire list. Now, in doing so here, we have 2 paired with 1, 5 with 5, 18 with 4, -3 with 3, 0 with 4, 8 with 2, and 9 with 1. So as we said in our definition of a function, look at your x's. Each x is paired with exactly one y. It appears that is the case in this example, and if you look at your x's, none of your x's repeat. We've got a 2, 5, none of them repeat. So each x is paired with exactly one y. Now, there are a few people who will say, well, wait a minute, I thought you said can't have the same y. We said each x, 9 is paired with 1, and I look up here, 2 is also paired with 1. So when I look at these, does that make this not a function? Each x is paired with exactly one y. Because I have different x's here, these all could be 1s, and we will still be fine. Each x, we have different x's, there's no repeating in the x's, we are fine. This would be an example of a function. Next question, Is it a relation? Any set of ordered pairs? It's not uneven. Each x is matched with a y. This is a yes in that case, so therefore you better say both. Now, looking at that one and looking at the big picture again, look at these next two, and I want you to evaluate them and come back to class with the idea of, are they a function, a relation, or both? Using the same ideas we just used in that last example. Now, up here, our direction is going to stay the same. State whether the relation is a function. But I don't give you ordered pairs in a chart. I give them to you in ordered pair form. Is that going to make it any different? Not really. If you like the other XY chart, you could write it that way. So I'm going to look at my ordered pairs. I have 1, 2, 4, 5, 2, 6, 9, 0. So right now, this is a relation. Every x is paired with one y. That's exactly what we need. Now, to test for a function, I'm going to focus on just the x values. 1, 4, 2, 9. Each of my x values are totally different. Each x is paired with a y. Each y, in this case, is different than the x's, which doesn't make or break the situation, but this one, we're good. So x's, none of the x's repeat. Each x is paired with exactly one y. We have a function. So yes, this one would be a function. If you would also look at these two and come to class with discussion on why they are or are not functions as well. Now we're going to head to the vertical line test. We know that graphs don't always show the ordered pairs in terms of x and y's on the graph. It would take too long to graph everything with showing every single point. So you are seeing some different looks at our ordered pairs, and they are now graphed as lines, as parabolas, as curves, as snakes, everything. Now, what you got to remember is each x is paired with exactly one y. So if each x, and I'm just making ordered pairs over here, if each x, so let's say if we had the point 3,2, and then we had the point 4,1, and then I came back and had 3 with 6. Each x is paired with exactly one y. So each x, I have a 3 for x, and I have a 3 for here. Each is paired with exactly 1. That's a 2, and this is a 6. That's not exactly one number. So this is an example where, no, it is not a function. But notice what happens because it's a no. If you graphed quickly 3, 2 over 3 up 2 and 3, 6 over 3 and up 6 on the same xy axis, you'd be getting a vertical line, and that vertical line would have two places where your points would cross, and that would not work. So we like to say, let's use that thinking on our new vertical line test. If a vertical line intersects a graph at no more than one point, then the graph represents a function. So you don't need to see the xy table or the xy values. You can just use your vertical line and test your graphs. So let's pull our vertical line over here and test our graph. So this first one, run it through your graph. Every single spot on your graph, it can only hit once. So that first one was an example of a function. We use it on the next graph. Again, it appears, yes, everything is only hitting that vertical line once, and therefore it is a function. So you would use your own vertical line and move it through the different graphs that you have, showing that it is or is not an example of a function. So do that, and again, we will have a little more discussion on that point when we return to class. We're working on substituting functions. We're going to continue to work on that. So if I gave you function notation, this is known as f of x notation again, and we want to solve it when x is 11 and then when x is 4. Remember, my key on these is you can only put in one of them at a time. So you would do, let's say, the 11 first, and you do the x equals 4 second. You cannot do them at the same time. So if we say evaluate, you're putting that x value in wherever there is a value, doing the math, order of operations, until you can't do anything else, and that number that results should be the value of that x value in your function. So try it. On this first one, we're only putting the 11 in, goes into the f of x position, into the rule, square, because that gets done in order of operations first, then the multiplication, and last but not least, the subtraction. So when we finish, f of 11 is 361, is the value we want to see on all of your papers. So again, try f of x equals 4. So when you put x equals 4 in, again, same situation, do the math. Order of operations is what tends to get some of you, trips you up, but keep that in mind as we go forward. So ordered pair, x, y functions, a lot of vocabulary. Try to keep it all in play. Come with some questions about what it means, about graphs, about how they work, what are the different ways you can look at ordered pairs and test whether they are functions or not. So that's all for section 1-4 today.